Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Today we're going to finish up our introduction to the scales on the slide rule. Now, in our first episode, we talked about the C and the D scale. Today we're going to talk about the A and B, the K, and the L scale. These are the basic scales seen on every slide rule. Now, after that, we're going to have two more videos. One is going to be on the trigonometric functions of the slide rule, and then we're going to talk about those LL, the log-log scales, and how they're used. After that, you'll have a very good working knowledge of how to use this rather remarkable tool. Now, there are a lot of advantages to using an electronic calculator, but there are some to this one as well. For example, how would you calculate an arc sine on a calculator if you didn't have a button for it? With this, all you have to do is put in the known sine of an angle, and you read straight up and it'll tell you exactly what the angle is. It's an arc sine. We'll go over that when we talk about trigonometry. In the meantime, we're going to go over the last of the basic scales, the AB scale, which deals with squares and square roots, the K scale, which deals with cubes and cube roots, and then the L scale, which is used to find the logarithm of a number. So let's cue up the music and get going. Well, let's go ahead and have a quick look at the theory behind the scales on a slide rule. Let's get rid of this. By the way, if you know what that is, you know what's coming. Now, the slide rule is basically two rulers that are stuck together and can slide across each other. And it's used for addition and subtraction on a logarithmic scale. So, for example, when you look at a slide rule and you see the number 2 on that, the length from the 1 is actually related to the logarithm of 2. Well, like in our last video, I'm going to go over the theory behind how the AB scale and the K scale works, and then we're going to go over and have a look at it on the slide rule so that you can just see it being done. Now, the CD scale is our basic scale on a slide rule, and that is the log of x. The AB scale is actually the log of x squared, and the K scale is the log of x cubed. So if you start with a number here on the CD scale and you move straight up, that's the square of that number. If you move down to the K scale, that would be the cube of the number. Now, if you start with a number on either the AB scale or the K scale, you go down and find the corresponding root of that number. Now, you'll notice that on the C and the D scale, it goes from 1 up to 10. Sometimes it's also marked as a 1. On the AB scale, you go from 1 to 10 to 100. And on the K scale, you go from 1 to 10 to 100 to 1,000. Since each of these scales has a full 1 through 10 complement of numbers on it, how do you choose which scale to use? So, for example, if you want to find the square root of 36, would you use the left side or would you use the right side? Well, I think your hint is the fact that it's written over the right side, that you would use the right side. Here's the rule. If the number has an even number of digits to the left of the 0, you use the right side of the AB scale. If it has an odd number, you use the left side. Likewise, on the K scale, if it has 1 digit, you use the first one. If it has 2 digits, you use the middle one. If it has 3 digits, you use the right one. If it has 4 digits, you go back to the left one again and work your way through. Now, there's a very good reason for this. Now, if you were to look at the numbers on the CD scale, you'll see that they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Because it's a logarithmic scale, that midpoint of that scale is between 3 and 4. If you start on the CD scale and go up, what's the square of 1? Well, it's 1. That's an odd number. Square of 2, that's 4. That has an odd number of digits. It just has 1 digit. Square root of 3, again, 9. Square root of 4 is 16. that has an even number of digits, and so on and so forth. So what you'll see is if the cutoff between the two is the square root of 10, which is approximately 3.16. So any number between 1 up to but not including 10, you would use the left side to get the square. Any number from 10 up to but not including 100, you would use the right side. Then you just start over again. These would be odd numbers of digits. Those would be even. So we'll go ahead and go down to the slide rule and have a look at this real quick, and you'll see how it works. Something similar occurs down here with the cubes. So for example, if you had 8, that's a single digit. You'd read it here. 27, that's the cube of 3. That would be here. 125 is 3 digits. That's the cube of 5, and that would be here. So let's go over to the slide rule and just see if we can make some sense of all of this. Okay, so the first thing that we're going to do is we're going to have a look at squares. Now the number that we're squaring is going to be on the CD scale, which is a continuous scale from 1 up to 10. So any number that we pick here, we can read straight up and we can read the square of that number. Now let's go ahead and do an example of that. So the first thing that we're going to do on the big slide is we're going to set the cursor right over the 1 in the middle of the scale, and as you see it falls between 3 and 4. It's about 3.16. Well, let's go ahead and pick any number on here, like 2. Now if we look at 2 and we read straight up onto the AB scale, we'll see its square, which is 4. Now here's the interesting thing. If you're dealing with numbers between 1 and 3.16, the answer to that is going to fall somewhere between 1 and 10. It's going to have a single digit to the left of the decimal place. But what if we aren't dealing with 2? What if we're dealing with a 3-digit number, for example? Well, 195 would be located right here on the CD scale. So if we were to look at 195, and we came up, we would come up to about 3, 8, and we're going to say 0. So where are we going to put the decimal place? We can determine the number of decimal places a couple of different ways. First of all, right next to it is 200, and if we square 200, we get 40,000. So that gives us one clue that it's going to be in the 10,000s range. The other thing is it's on the odd side of the AB scale. So it's probably going to have 5 digits rather than 4. So if we read up, we see that it's 3, 0.5, 0.6, 0.7, 0.8. 3.8 probably times 10 to the 5. And if you do the math on the calculator, it comes out to 3825. Now if we do the same thing to a number that is to the right of the midpoint, such as 4, we read up to its square, what do we get? We get 1.6. Okay, well what is that? That's 16. Again, we're dealing with 4, which is 4 times 10 to the 0, but it's on the right side of the AB scale, so it has to have an even number of digits. We know that it's going to be more than 9 because 3 is the square root of 9, and we also know that it's going to be less than 100 because the 1 for the 100 is all the way out at the right side of the slide rule. So the only plausible answer is 16. Now let's go ahead and have a look at a couple of numbers and we'll find the square roots. Now 8.5 has got 1 digit to the left of the decimal place. We're going to find 8.5 on the left side of the AB scale. And then we can just read straight down and get its square root. Well, there's 8.5 on the AB scale. And if we read straight down to the square root, we're going to get 2.92, it looks like. And if we go ahead and pull it up on the calculator, there it is. Now, how about 82.6? Well, it's got 2 digits to the left of the decimal place. So it's going to be over here on the right side of the scale. And we're going to use this 82.6 here. So there's 81, 82, 82.6. So let's go see what we have here. Looks like about 9.9 or so. Let's go see what it is. And there it is, 9.88. 9.088. Pretty doggone close. There's 3, 3.1, 3.2, 3.4, almost 3.5. We read right down. What do we have on the C scale? Well, we have 18. Well, we have 17.9. Now again, this is 3.24 times 10 to the power of 2. We're probably going to get an answer somewhere in the vicinity of 10 to the power of 1 because we're taking the square root. 1348. How many digits? 1, 2, 3, 4. So it'll be over on the right side. And where's it going to be? Well, here's the 1. We're going to go up to 13.5. So we'll come down to the CD scale and we'll come up to 35, 36.6. And there's our answer. Let's go ahead and go down and have a look at the K scale. Now the K scale on this slide rule is all the way down here at the bottom. So here's the first division. It goes from 1 to 1. And then it goes from 1 to 1. And then 1 to 1. So this would be ones. This would be tens. This would be hundreds. Then we come back to thousands, 10,000s, 100,000s, million, 10 million, 100 million. Do you see the pattern? 1, 10, 100. On the Aristo, the K scale is actually up here just above the CD scale. So, once again, when we cube things, all we have to do is go right to the CD scale and we cube them. So 2 cubed, we read up to the K scale and it's 8. 4.5 cubed, we read up again to the K scale. We're in the 10 range, and then this is the 100 range. So 4.5 cubed, what would that be? So this is obviously in the 90s, and it looks like it's about 91. And there's our answer. So to effectively do this, one of the things that you have to do is you have to have kind of a working knowledge of a few key cubes. Like, for example, the cube of 2 is 8. The cube of 5 is 125, and there's 125 on the K scale. So here's 100, 110, 120, and it's at 125. Now, let's go ahead and find the cube root of these same numbers. So the first one was 8.5. That's going to be here at the far left. So we're going to use the first part of the K scale. Okay, there's the one that separates the first part, the left part, from the center part. And we're going to go to 8.5. There it is. Then we're going to come down and read on the CD scale what the cube root of that is. The cube root of 8 is 2, so it's a little bit more than 2. That gives us our order of magnitude. And according to this, it looks like it's about 2.1. So let's go see what this says. That says 2.04. I really should have worn my glasses for this. That's the one disadvantage of a slide rule. Now, the next one that we had was 82. Well, that's got two digits in it, so we're going to use the middle part of the K scale for that. And that goes right to here. So there's 82. Now, once again, the cube of 5 is 125. So we know it's going to be less than 5. So what we'll do is we'll read straight down, and it looks like we've got 4, 4.1, 4.2, 4.3, 4.4. It looks like about 4.34. So let's go see what we have there. We have 82.6, and we're going to take the cube root of that. 4.34. Now we're going to go to 324.99. That's about 325. So 3 digits. So we're going to be in the third part of the K scale. And we're going to go right up here to 310, 325, right there. Now we're going to come down, and what's our cube root? Looks like it's going to be 6.78, 8.86, 6.86, 6.87. Here's the 6, 6.87. And finally, we're going to have 1348. Okay, so we're going to be back on this side of the scale, the far left. Here is 1, here's 2. So 1.1, 1.2, 1.3, 1.35. That's 1350. Now we're going to read straight down. It looks like it's about 11, because here's 1, here's 1.1, and it's just past it, and there's 1.2. Now when it comes to the log scale, finding the mantissa is actually rather easy. All you have to do is take the number that you're raising to a power of 10 and find that number on the log scale. So on this slide rule, the L is right here underneath the B scale, and that's the log scale. So all we have to do is we have to come up here. We're looking for 3.67, so there's 3.5, 3.6, and I'm going to call that about 3.7 right there. So all we have to do then is read up here to the log scale, which is right here, and we're going to get 5.5, or we're going to get 5, 5.5, 5.64. Now, 3.67 is going to give us 0.564. Now, the first number that we did was 367. That's 3.67 times 10 to the 2. So our log is going to be 2.564. Then we've got 36.7. That's 3.67 times 10 to the 1. So the log 10 will be 1.564, because remember, the 564 comes from the 3.67. Now this is 3.67. That's 3.67 times 10 to the 0. So the log will be 0.564. Now the next one's a little bit tricky. What we're dealing with here is 0.367. Now following our argument, we should think that that would be minus 1.564. So let's go ahead and check these. So the first one is going to be 367, and we're going to go log 10. 2.564. Then we're going to go 36.7, log 10, 1.564. Okay, we're cooking with gas. Then we're going to do 3.67, 0.64. Again, pretty good. Now, 0.367, and we're going to do log 10. Ooh, that doesn't look right. Let's do that one again. 0.367, log 10. We got a different number. Do it one more time just to make sure. 0.367, log 10. Yep. So that's wrong. That's actually negative 0.435. Now, why is that? Let's go over to the board and find out. Now, the cause of the error is deceptively simple. It has to do with the way the slide rule works. It's a linear scale. So when we look at 367, the first thing that we look at is that's a 10 to the 2. Well, this spot right here would be 1 times 10 to the 2. To get up to 3.67, we have to move that way. Likewise, when we're dealing with 36, that's 10 to the 1. That spot right there is 1 times 10 to the 1, and we have to move that way to get to 3.67. 3.67, well, that spot right there is 1. Again, we're moving that direction. But what about 0.367? Well, what's 10 to the negative 1? Well, that's 0.1, right? What do we have to do to get to 0.637? We have to move that way. However, that's 0. So what we really want to report is that right there. So if we started at this point and move forward 0.564, in order to get this number, we have to take 1 and subtract that number from it. And as a result, we get 0.435. And that is the correct answer. And we have a minus in front of it. You just have to remember that they're measuring from one of whatever power you're dealing with, moving from left to right. So I hope that was a good introduction to the basic scales on the slide rule. Next time we're going to have a look at the trigonometric functions, and they're actually a lot of fun. And then we're going to have a look at the log-log scales. The trigonometric functions will allow you to find angles and sines, cosines, tangents, etc. The log-log scales are actually very interesting. And one of the problems that we're going to address with a log-log scale is going to be carbon-14 dating. And the other one is the geometric mean of a series in statistics. So until then, this is Bob the Science Guy. Thank you very much for stopping by, and I hope that you found this interesting. I have a lot of fun with these things, and I think you will too. So go on to eBay, get yourself one, and start playing with it a little bit. You'll find that you'll use it more than you think. Take care, guys.